Alright, today I'm going to show you one more way to solve a quadratic. Remember, solving a quadratic is to find out where the x-intercepts are, or where the parabola hits the ground. We've done this by using a t-chart, graphing it, and finding the zeros. We've also done this by factoring, setting the equation equal to 0, since y is equal to 0 at the ground, and finding them that way. Today we're going to use the concept of balancing the equation, meaning what you do to one side you do to the other to keep it balanced, and we're going to complete the square. Now, I know that if I looked at this problem in a test, I would probably do this by factoring. However, not every equation can be factored, and that's where completing the square is very useful. It's also very useful for deriving formulas in upcoming sections. Alright, so what we're going to do first is we're going to artificially create a perfect square. So the way that we do this is we're going to add a value to both sides of my equation that would create a perfect square on this side. So to create a perfect square, I know that the c value is half of the b value squared. So I take negative 4, divide it by 2, I get negative 2. And negative 2 squared is going to give me a positive 4. So I'm going to add a positive 4 to both sides of the equation to keep it balanced. Now I can rewrite this equation as x minus 2 times x minus 2, or x minus 2 squared. And the other side of my equation now becomes 1. Now again, I have a squared on this side, and I know that I can get rid of it by square rooting it. So what I do to one side, I do to the other. The square and a square root cancels out. I'm left with x minus 2. And on this side, I'm left with positive or negative 1, right? Because negative 1 times negative 1 is positive 1. So I have two different choices when I'm taking the square root. We don't do that on this side because we have a variable. We don't know what that is yet. All right, the last thing we need to do is just solve this. This actually creates two different problems. So we have x minus 2 is equal to positive 1, or x minus 2 is equal to negative 1. Now when we solve this, we will end up with x equaling to 3, or x equaling to positive 1. So it's going to hit the ground at positive 1 and positive 3. Again, this factored out really nicely. We could have done factoring. Now let's look at this problem here. If we tried to factor this, there is no factors of 10 that add up to negative 6. So this is not going to give us a pretty number. It's going to give us some yucky decimal. And of course, in Algebra 1, we're not allowed to use our calculator, so we need to use radicals to figure this out. So what we're going to do first is we're going to get the x squared minus 6 alone, because this 10 does not give me a perfect square. So I'm going to add the 10 to both sides. And now I'm left with x squared minus 6x and 10. Now I'm going to add what I need to this side to artificially create a perfect square. And if I add it to both sides, I'm not changing the problem, I'm keeping it balanced. So I take my negative 6 divided by 2, we get negative 3, square it. Negative 3 times negative 3 is positive 9. Remember, always positive. And we add that to both sides. Now I can rewrite this as x minus 3 times x minus 3, or x minus 3 squared. And this side here is 19. All right, I can take the square root of both sides to solve this and get rid of my squared. Squared and a square root cancels out. I'm left with x minus 3 is equal to positive or negative square root of 19. If we had a calculator, we could plug that in and get a fabulous decimal, but remember, we're going to write it in a radical form since we don't have a calculator. So we're going to have x minus 3 is equal to positive square root of 19. X minus 3 is equal to negative square root of 19. And when we solve that, we'll have x is equal to 3 plus the square root of 19, or x is equal to 3 minus the square root of 19. This method can be used on any quadratic that you have, whether it's factorable or not, and you can make sure you get your accurate answer. And remember, you know you love math.